Welcome to this video on exploratory data analysis. Today,
Yeah,
we are
perfect.
going to understand this popular and valuable concept with a story. We will cover the concept of exploratory data analysis, that is EDA, where it fits in the business analytics cycle, its importance, and the steps. Anna is a business data analyst and is worried about meeting tight project deadlines. The business stakeholders need insights on why customers are churning and how to prevent that. So, she proposes to her manager Jatin that we skip the exploratory data analysis part and move on to the actual data analysis. She suggests asking the data scientists to share the machine learning algorithm best suited for this business requirement. Jatin listens to all the details but tells her that he disagrees. He tells her that EDA is the foundation stone, a vital step before the data analysis begins. EDA techniques reveal the true nature of the data. It is very similar to an investigation carried out by a detective. Now intrigued, she wanted to know more. He explains that EDA is digging deep into piles of data to find clues that will aid the actual data analysis, like a detective. The better you know your data, that is, have more clues, the better is your analysis, that is, the case outcome. He also tells her that learning what you can do using the data available will make your final analysis more robust and effective. Open minded exploration of data will provide valuable information. It is all about finding and revealing clues. Anna is excited and wants to know more. She is wondering about the different ways in which EDA can help. So Jatin explains that the first objective of EDA is to confirm if the collected data makes sense in the context of the business problem that we are trying to solve. If not, we need to collect more data or change the strategy. Imagine the time and amount spent if EDA was not done, and you realize that the data is not suitable for the analysis halfway through. Now, you would be very lucky if the data you get or collect is clean. This is hardly ever the case. EDA is helpful to uncover and resolve data quality issues like missing data, duplicates, incorrect values, that is, anomalies, incorrect data types, and the list is very long. The EDA reveals the data summaries like the descriptive statistics like mean, median, standard deviation, etc. All these are very important to know before we draw any conclusions from the data. Many times, some values may lie far away from the standard set of values. These are called anomalies, and they need to be verified before they go into data analysis. If unchecked, they will
Once
create havoc in the
you have
analysis,
completed
misconstrue
going through that
calculations.
video, just let me know.
Using
Okay.
EDA, we may uncover the behavior of variables when clubbed together. Their correlation tells us how much and in which direction we should expect one variable to change when the other changes. It is a value between -1 to +1, indicating a strong negative or strong positive relationship. Correlation plays a vital role in locating the crucial variables on which other variables depend. Not all columns from the data we have collected are helpful for our analysis. Also, we may often need to create new columns from the columns we have using business knowledge. EDA can play an important role in this process. Hannah agrees that EDA is a vital step before the analysis and will save a lot of time and effort if done correctly. Jatin explains that EDA is done once we have defined our business problem or opportunity and have our data ready. So, before the analysis, we know whether the data is appropriate and take corrective action if required, or what the data looks like, how it can be prepared for the analysis, and so on. Now, Jatin and Anna decide to work on the EDA for the data that their team has collected. So they start with univariate analysis that looks at single variables like age, salary, and so on. For the categorical variable like area code, a simple tabulation of the frequency of each category is helpful. They find that area code 415 has the highest number of customers. For numerical variables, they use descriptive statistics summary to get details like mean, mode, standard deviation. As a starter, this tells them that there are some missing values which need to be resolved before the analysis. Next, they move on to visualizing univariate variables. Categorical data can be easily represented by a bar chart. This chart tells us that West Virginia has the highest total day calls, a strong customer base. For quantitative data, histograms, which are bar plots in which each bar represents the frequency or count of the cases for a range of values, are very useful. They help in understanding the central tendency, spread, shape, and outliers. This histogram reveals that customers with account lengths between 90 and 180 have a higher tendency to churn. Maybe some offers or loyalty points can be introduced. Now, Anna is happy that they are getting so much information already. They move on to multivariate non-graphical analysis, where two or more variables are analyzed together. Cross-tabulated reports of two or more variables fall into this category. A simple report tells us that customers who don't have an international plan are more likely to churn. In case of graphical analysis, scatter plots, which help visualize two quantitative variables, have one variable on the x-axis and another on the y-axis. They saw a pattern that customers with low day minutes and high service calls have high churn rates. So, EDA is generally cross-classified. It can be done non-graphically or graphically and is further divided into either univariate or multivariate. Further analysis revealed many insights which proved the importance of EDA before the actual analysis. Now, Anna was convinced and happy to have such a supportive mentor manager. Thank you for joining us today, and I hope the EDA concept is clearly understood. And yeah, check out more about the exploratory data analysis using Excel course.
Okay, I'll share with you another link. Okay, you need to go through that as well. Yeah, I have shared the link with you here as well as on the unofficial group. Please see.
Hey everyone, it's a great day in sports analytics. I'm Victor Holman, sports analytics expert, and welcome to the Sports Analytics 3-Minute Drill, where I break down sports analytic methods and explain how they're being used today in the world of sports. Today we're going to discuss linear regression in the NBA draft data research conducted by Daniel Sailovsky. So let's begin. Linear regression is a linear approach to modeling the relationship between a scalar response or dependent variable and one or more explanatory variables or independent variables. The case of one explanatory variable is called simple linear regression. For more than one explanatory variable, the process is called multiple linear regression. This term is distinct from multivariate linear regression, where multiple correlated dependent variables are predicted rather than a single scalar variable. Every year, NBA teams struggle to determine who their coveted draft choices should be. This study focuses on the choices that teams have made in order to analyze decision-making biases and errors. The data for this research came from the NCAA players who were drafted by NBA teams between the years 2006 and 2013. Information regarding the draftees' court statistics, conference they played in, the year they were eligible to be drafted, and the year they were rookies. Data was collected regarding their performance after they joined the NBA, including where they were picked in the draft, their pre-draft physical measurements, as well as statistics regarding their performance and length of their career. This information was analyzed to determine how well NBA teams were choosing their draft picks based on their performance after they joined the NBA. The conclusion was that good decisions were not being made when selecting draft choices. The research indicated that most of the factors used to determine who to draft did not relate to the player's future performance. Teams typically want to draft players from well-known colleges that belong to conferences that are traditionally considered strong. It is human nature to avoid change, and those making the draft decisions are no different. They are more familiar with the big conferences, so they feel safer drafting those players. They fail to take into account the strengths of players from other conferences and, as a result, are often not choosing those players who have the best chance of making a difference in the NBA. Research has shown that players who have strong skills regarding ball control and preventing turnovers do well in the NBA. However, these skills have no correlation to the players who are actually drafted. Players with a high rebound percentage and free throw rate in college do better in the NBA than other players as well. However, again, these statistics do not relate to those who are actually drafted. The research seemed to indicate that those players who make memorable plays in their college days are the ones who are drafted. NBA teams also tend to look at scoring and block shot statistics when choosing draftees, but these skills do not actually predict future NBA performance. NBA teams tend to be more interested in the younger, less experienced players. Statistics show that teams are more willing to take on players who have the physique of a typical NBA basketball player, even if they lack high-level basketball skills. NBA teams will overlook these
Yeah,
players'
once
weaker
you are done
skills,
going through
believing that
that
with
video
proper
as well,
coaching
let me
these
know.
players will become
Okay.
better. Unfortunately, size does not guarantee skill levels, and no amount of coaching will be able to make these players effective NBA players. Height is positively correlated to draft position, but height is not correlated to future performance. Research shows that scoring is positively related to a player's draft position, but is actually negatively correlated to future performance. Of course, scoring is a skill necessary to be effective at the NBA level. However, there are other factors that are related to future performance. Star players in the NBA were also strong shooters in their college days. However, they would have strong skills in other areas as well. In conclusion, teams need to look carefully at how they choose who to pick in the draft. They need to determine what characteristics are related to a college player becoming a strong player in the NBA and leave their biases behind. Thanks for watching this video, and I hope you found it informative. If If you'd like to learn about a groundbreaking approach for leveraging analytics,
Okay, perfect. Yeah. Any of you have doubts regarding, what we discussed earlier? I mean, before the session, before the break. Predictive analysis example. Okay. Example from the video that I had forwarded to you. Are you referring to that one? The EDA. Okay. Understood. All right. Let me bring up that page for you where I had written it, where I wrote it. I come to think of it, it's better that I explain it to you once again. Okay, this is what you're referring to, isn't it? Shreya, right? Oh, perfect. See, as I was saying earlier to you, we have something called predictive modeling, right? So we defined predictive modeling as something, okay, which we perform, or this is a predictive modeling is a what is it, series of code, or steps, or a technique that we perform on the data, okay, on the data, to mainly gain an insight as to what is likely to happen, right? Okay, you can call this as insight. You can call this as forecast. Both are one and the same. Okay, so given, okay, someone texted me. Okay, yeah, that is your lecturer texting in your group. Okay, anyway, let us not deviate. Let's get back to this. Okay, predictive modeling. Predictive modeling is mainly used to gain an insight, or a forecast, insight or a forecast into what is likely to happen. Forecast itself means that, okay, predicting a future event in itself is called a forecast. So we went into it, and we saw what kinds of questions that does predictive modeling might try to answer. It is not what do you say? It would be uh, very forward of me to say that predictive modeling is accurate, but we can at least predict what is likely to happen with certain good percentage of accuracy. So that is what we call as actual outcome and expected outcome. Again, that comes into picture here. Expected and actual outcome. So here, expected outcome is what we get from predictive modeling. Then we saw what kinds of predictive modeling we do. We use regression, we use classification, okay, and we use time series models, and we also said that we use ensemble models. So there are four kinds of what do you say, types of predictive modeling: regression, classification, time series modeling, and ensemble modeling. So we looked into what these things are in further ahead. But as to the doubt what you asked me, okay, injury prediction. Okay, injury prediction. Okay, okay, yeah. So predictive modeling, and also what do you say, descriptive analytics. Yeah, I'm getting there. I'm getting there. Don't worry. Okay. So in predictive modeling, we are going to focus on forecasting. Okay. Here it is, a summarization of what has happened. Okay. Okay. Here it is a summarization of what has happened. Okay. Get this very clearly. Okay. This is a, very, there is a very thin boundary line where, you might get confused like you just did. Okay. So here what we'll be doing is we'll be using charts and summaries. We'll be using charts and summaries. And we'll be using algorithms and simulations. And I also said that, we'll be, looking at an example such as, average number of goals per match, and here probability of winning in the next match. Right. Then I also told you that performance review is a example of descriptive analytics, and tactical planning is a use case example of predictive modeling. Right? Okay. When I brought in the concept of exploratory data analysis, can you tell me what exactly is exploratory data analysis? Yeah, you can unmute yourself or you can type. Either way is fine. I think we saw exploratory data analysis in the last class, isn't it? EDA, right? Still here with me? No. Yeah. What exactly is exploratory data analysis? Just before I started explaining you the program in the last class, I think I told you what exactly is exploratory data analysis. Okay, let me just repeat for your sake. Okay, it is basically a process. Exploratory data analysis, or EDA as it is called, is a process. Okay, for understanding. Okay, for understanding data sets. Okay, using okay using visualization and also statistics. So let us say there is a data set given to you. Okay, what we'll be doing is, before we get into the feature selection, model selection, what kind of predictive modeling do you want to conduct upon that data set, and what kind of depending on what kinds of insights you want to obtain ultimately at the end. Before you do all this, what you will be doing is, you'll be performing an exploratory data analysis on a data set, wherein it summarizes everything that is present in the data set, such as features, parameters, parameters as in the values, the kind or type of data set. Okay, these are a part of summarization. These are a part of summarization process. Exploratory data analysis is of two types: summarization and visualization. Okay. So the first step, summarization, basically gives you what features, what parameters, values, what kind of type, what is the maximum, maximum. Sorry, not maximum exactly. What are the top 10 values? Okay, what are the lowest 10 values? Okay, within the data set. Okay, how many number of categories are present, or categories of features are present. Okay, all these things are a part of summarization. Okay, right. Then after that, we will be also performing something called statistical analysis on this data set as a part of EDA. This is the second step. So what you will be doing is you will be exploring concepts and you will be, what is applying concepts such as mean, median, mode to the data. Okay, and you will also be, subjecting the data set to visualization. You'll be what essentially you'll be doing is you'll be constructing graphs with, the features and parameters, and values. I told you this, right? If you remember. Yeah. Okay. So this itself is a part of descriptive analytics, isn't it? What is descriptive analytics? It describes you what has already happened. It provides you charts and summaries. Don't you think this is EDA, right? Then statistical concepts such as average, goals per match, performance reviews conducted. So basically, descriptive analytics. Okay, descriptive analytics include performance of EDA on a particular data set, right? Yes. Okay. Within this data set, there is already there are let us say there is a let us take an example of cricket team. Just humor me, how many number of players are there in a cricket team? 11, 12. 11, right? 11 players. Let us say player let us say player one. Okay, let us say the data set. Okay, consider the data set first. Let us say the data set consists of data pertaining to Indian cricket team. Let us name these players from P1 to P12. P sorry 11, right? 11 players. P11. Okay. Let us say the data set consists of all the data pertaining to Indian cricket teams matches. Okay. T20, test series, and also let us say ODI. Let us also say World Cup. Okay, all this data is present in the data set. Let us say a particular P3 has already injured, was injured. Okay, was injured in let us say T20, let us say in ODI as well as World Cup. Okay, the only place where he was not injured was in test matches. Let us just assume. Okay, so descriptive analytics has already outlined where, okay, when the player was injured and where exactly was the player injured. Okay, when it comes to predictive modeling, when it comes to predictive modeling, okay, let us say T20 matches were done, ODI matches were done, and World Cup matches also done. Let us say the same player is playing in Test series, and we want to determine the likelihood of this particular player P3 getting injured even in Test series. So what we need to do is we'll apply a predictive modeling. We'll use a predictive modeling to predict or to forecast the likelihood of the player getting injured even in test series. Likelihood of player getting injured. Where exactly? In test series. Okay, so I'll be using, for example, in this case, I'll be okay using something called uh, let me do it. Sorry, just give me a sec. Yeah, sorry for the interruption. Excuse me. So let us let me get back. Okay, let us say the player was injured both in all T20 ODI and net World Cup series. Now he's entering into Test series, and I want to determine the likelihood of this player getting injured even in the Test series. Okay, so what we'll be doing is logistic, we'll be applying logistic regression on the biometric data, on the biometric data pertaining to biometric data of whom this particular player P3, biometric data of P3 to determine the likelihood of this player getting injured even in Test series. The fourth consecutive, sprint injury or injury sprint, whether or not he's on an injury sprint, will determine it by performing a logistic regression on this biometric data. Okay, and what exactly is a bias here? What exactly is a bias here? Yeah, the question was to you, for you, Shreya. What exactly would be a bias here in this case? No, that is a conclusion, an observation, not a bias. Bias here, if the predictive modeling is biased, okay, if the predictive modeling is biased, then it can lead to imbalanced classes. Here it is a case of imbalanced classes. How many features are here? There are only four kind of features here. What are those? ODI, World Cup, T20, and Test series. So the injury, okay, the injury parameter or the injury feature here. The injury feature here was true, 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 and we need to determine the fourth one. So here one outcome is dominating, right? One outcome is dominating. So even after performing a predictive modeling, if the model fails to factor in the biometric data, okay, if the model fails to factor in the biometric data and instead draws a conclusion or forecast of a player getting injured without factoring in the biometric data or ignoring the biometric data, then it is leading to imbalanced classes and it needs rectification, right? So in these instances, in such instances, we'll be looking at descriptive analytics. Okay, why exactly? Descriptive analytics basically summarizes all the features, parameters, values, top 10 values, lowest 10 values, number of categories. But not only that, they perform a statistical analysis on these things. So even within the, what do you say, whether or not, as you said, general health condition could be bad. This generally, is summarized whether or not the, uh, player has a bad health is basically summarized within descriptive analytics, which is a part of EDA, right? So EDA not only helps to form a a foundation or basis for predictive modeling, but it also helps you to summarize, gain insight, okay, as to what the data set is. It also helps you to, uh, you know, it also helps in feature selection. Feature selection as in what kind of modeling you want to use. And also it helps you in model selection. Feature selection as in which kind of, model you want to use. Sorry, which kind of technique you want to use. Regression, classification, so on and so forth. Right? Isn't it? So the point what I was saying is both are interdependent on each other. First, EDA is performed. EDA leads to descriptive analytics. Then, based on descriptive analytics, you have feature selection and model selection, and after that, you will be performing a predictive modeling. Then, if something goes wrong with it, you will be again, what do you say, going back to your initial EDA step to refer what went wrong. If everything is good, if everything falls as expected, okay, we'll be taking the output as expected output, right? So this is a general process. That is what I was trying to say. EDA and both, are interdependent. Are interdependent. Okay? EDA and predictive modeling are interdependent. Again, descriptive analytics. Within descriptive analytics, will be EDA is leading to descriptive analytics, and both EDA and descriptive analytics together help you to choose and properly select a predictive modeling, help you perform predictive modeling on the data set. That was what I was trying to point out to you. Anything else? No. Yeah. Perfect. Okay, there are some updates going on, to my Google Colab notebook, which is why I got delayed in joining this session. Okay, once that is done, I'll be, uh, practically, I'll be explaining you the lab program 1 and 2, while coding it live to you in the next session. Okay. So let me refer to what do you say, the your WhatsApp group. So 27. So do you have any session tomorrow scheduled for tomorrow? If so, let me know. Okay, even if it is cancelled, let me know. Okay, I think your CR can, let me know just whether or not the class is cancelled, that is, generally scheduled for tomorrow. Let her communicate with me. So depending upon the availability, I plan to conduct a session tomorrow. Okay. If not, the next session will be on Sunday, right? How do you take the attendance? Okay, just take the screenshot of people who are present in the beginning of the session and mark them attendance. That's it. Yeah. And sometimes even during the end. That depends. Some of you have just, dropped all of a sudden right now at the end of the session. So yeah, let us see. That is a trade secret which I cannot reveal, of course. You understand. Okay then. See you in the next session. Either tomorrow or Saturday, either tomorrow or Sunday, depending on whether or not the class is cancelled tomorrow. Right? Okay. That's it for today. Yeah, perfect. Yeah, and I also, before you leave, I also posted a video from IIT Mumbai, okay, an NPTEL course video. It is 95 and 95 minutes and 25 seconds long video. Okay, it outlines and it describes in detail what exactly are predictive analytics. They go into problem solving, everything, and they also cover the topics of regression and classification. Okay, please go through it, before the next session. Okay, so that you will get a detailed understanding. Meanwhile, I'll type out a notes and prepare a PPT for you with the, what we discussed today, and I'll post it into the Google Classroom. Okay, that's it. Those are the updates for you. See you all in the next class.